Okay, in our next proof, our given is that M is the midpoint of segment AB. AM is 2x plus 10, and AB is 6x minus 10. So that is our given. So I'm definitely going to want to draw a picture. So here's M. It's the midpoint of AB. And I know that if M is the midpoint of AB, that means that segment AM and segment MB are going to need to be congruent to each other. So segment AM needs to be congruent to segment MB by the definition of a midpoint. Sorry, that's supposed to be an M. I don't know why it won't draw a line there. Oh well. Okay, notice this expression has a congruence symbol, whereas our other pieces of information have equal signs. So we're going to need to switch from our congruent symbol to an equal sign. So when I switch from segments being congruent to their measures being equal, to their lengths being equal, that is the definition of congruent segments. And you can draw the congruent symbol instead of writing the word congruent. Again, when I switch my segments from being congruent to being equal, when I take the hat off the equal sign and I take the hat off the segments, that is the definition of congruent segments. Oh, segments, plural. Whoopsies. Okay, now I know that segment AM is 2x plus 10. Oh, I'm sorry. And segment AM is equal to MB. My AM repeats. I have three terms, three colors, 3, T, transitive. And so now I can say that MB is equal to 2x plus 10. Which makes sense because if M is the midpoint, the AM and MB have to be the same. But definition of midpoint only allows us to say that those two segments are congruent to each other. We had to go through this whole process of switching them from being congruent to equal and then using the transitive property to say that they were both equal to 2x plus 10. So this is an example of where proofs can get a little hard. It's not always exactly straightforward and obvious as to what see, look at me trying to write and talk at the same time about two unrelated things. It usually doesn't go very well. I started writing a completely different word. Transitive property. This is an example of where it's not always obvious which route you're going to take to complete a proof. And the more proofs you do, the more you start to pick up on patterns, and the more your brain starts to start thinking like a mathematician and start recognizing, oh, well, if I know this, then most of the time I can say this. So don't get discouraged with proofs. We're going to practice, and we're going to practice, and we're going to practice. And the more practice that you do, the easier it gets. Okay, so let's sort of think about where we're at. We know that AM and MB are both 2x plus 10. and I'm trying to solve for x. I'm looking at my end result. I'm trying to prove that x is 15. So I'm going to have to solve for x. But that's going to mean I'm going to need to set up an equation, and I only know that AM and MB are equal to each other. If I set 2x plus 10 equal to 2x plus 10, that is not going to help me at all. Like, everything will cancel out. So I'm going to go ahead and I'm going to take my expressions and I'm going to put them on my picture. That might help jog my thought process a little bit. AM is 2x plus 10. And B, we just proved, is 2x plus 10. And then they also give us AB. They also give us AB is 6x minus 10. Your givens are there for a reason. We tell you things in the given because we want you to use that information. So this is a big flat red flag to me. Like, I put AB is equal to 6x minus 10 there for a reason. I'm going to use it in my proof. So a long time ago, we learned about this thing called the segment addition postulate. Part plus part equals whole. We have our two parts and we have the whole enchilada. Let's use segment addition postulate. So step 5, I'm trying to set up an equation. So let's do segment addition postulate. AM plus MB is equal to AB. Part plus part equals whole. That's the segment addition postulate. Now I can go substitute everything into its correct place. AM is 2x plus 10. And B is 2x plus 10. And AB is 6x minus 10. Substitution. Okay, I'm going to go ahead and jump over. In step 7, my next step will be, I'm going to combine like terms. I have x's I can add together and I have whole numbers I can add together to get 4x plus 20 equals 6x minus 10. That was just simplify. All I did was combine like terms. Now I'm going to subtract 4x from both sides, which will give me 20 equals 2x minus 10. Subtraction property. Now I'm going to add 10 to both sides to get 30 equals 2x. Addition property. Then I'm going to divide by 2 on both sides. Division property. And then I need to make sure that my last statement of my proof matches my prove statement perfectly. And so finally I'm going to do the symmetric property. So this last half of the proof should have been fairly easy because it's just solving an algebraic equation and y'all are really good at those. So this looks like a really long proof, but half of it is pretty basic. So let's sort of recap what we did with this proof. We knew that M was the midpoint of that segment, so that meant that these two segments, segment AM and segment MB, had to be congruent. But we only knew that AM was 2x plus 10, so that meant that we only knew that MB was 2x plus 10, and so we couldn't just set them equal to each other and solve for x because they're identical expressions, and so everything would cancel out when you're trying to solve for x. So we had to think a little bit more creatively. We had to think, okay, if I have a segment, if I have a point M in between 2 points, then I can use the segment addition postulate. Part plus part equals whole. So I set up segment addition postulate, and then I could go plug everything in, go substitute everything into its proper place. I just realized I didn't write property after the word substitution. Shame on me. Always got to write property, even if it's PROP. So this one is definitely a challenge of a proof. So don't be discouraged if you're like, wow, that was really long. It was really long, but you can do it. Yay!